Let's start chapter 10. We're going to start learning about circles, and we have a lot of vocabulary to start out with. Some of the vocabulary is going to be review from previous years' learning, and some of it's going to be a little bit new. Oh, goodness. Sorry. I realized I forgot to... There we go. First of all, a circle. A circle is a set of all points in a plane that are equidistant from a given point called the center of the circle. The center. A circle with a center P is called circle P, which can be written circle with a dot in it, P. A radius. A segment whose endpoints are the center and any point on the circle is a radius. A chord is a segment whose endpoints are on a circle. Diameter. Chord that contains the center. Secant, a line that intersects a circle in 2 points. And a tangent, a line, ray, or segment in the plane of a circle that intersects the circle in exactly 1 point, the point of tangency. But here's a diagram to help. So I'd recommend putting this diagram in your notes and going back to the previous slide and making sure you have all the definitions written down. We can't talk about the chapter very well if you don't understand the vocabulary of all the pieces of a circle. Example 1. Identify special segments and lines. So first, tell whether the line, ray, or segment is best described as a radius, a chord, a diameter, a secant, or tangent of circle C. Segment AC. AC is right here. And that looks to me like it is the radius, because C is the center and A is a point on the circle. AB. AB is right here, which is the diameter, because it is a chord that contains the center C. Ray, DE. DE is right there. It is a tangent ray because it is contained in a line that intersects the circle at only 1 point, the point of tangency. AE is right there. AE is a line. AE is a secant because it's a line that intersects the circle in 2 points. All right, you try. In example 1, what word best describes AG? AG is right here. AG looks to be a chord. Remember, a chord's definition is a segment whose endpoints are on the circle. And then we have segment CB. CB is a radius. The radius is a segment whose endpoints are the center and any point on the circle. In example 1, name a tangent and a tangent segment. A tangent's any line, segment, or ray that touches a circle at just 1 point. So I have a tangent is, we're going to say line, DE is a tangent. And a tangent segment, let's say segment DB or segment BE. Radius and diameter. The words radius and diameter are used for lengths as well as segments. To name a segment, you can use radius and diameter, or to talk about the length of something, you can use the words radius and diameter. For a given circle, think of a radius and a diameter as segments, and think of the radius and diameter as lengths. Also important to know is the plural of radius is radii. All radii of a circle are congruent. Example 2, find lengths in circles in a coordinate plane. I have circle A. The radius of A is a segment that contains the center to a point. So if these are in ones, we're 1, 2, 3. The radius of A is 3. The diameter of A is 1, 2, 3, 4, 5, 6, or twice the radius. The radius of B is 2, and the diameter of B is 4. Use a diagram in example 2 to find the radius and diameter of circle C and circle D. The radius, 1, 2, 3, circle C. The radius is 3. The diameter is twice that, which is 6. 1, 2, 3, 4, 5, 6. D, circle D. The radius is 2, diameter is twice that. Coplanar circles. Two circles can intersect in 2 points, 1 point, or no points. Coplanar circles that intersect in 1 point are called tangent circles. Coplanar circles that have a common center are called concentric. These are all things that we need to know. Concentric, they have a common center. 1 point of intersection is tangent. 2 points of intersection. Common tangents. A line, ray, or segment that is tangent to 2 coplanar circles is called a common tangent. A line that intersects a circle in exactly 1 point is said to be tangent to the circle. So I have 2 circles and a line that is tangent to 2 circles, so it has a common tangent. I could also draw this common tangent this way, or this way, or that way. 4 different ways I can draw a common tangent. Here I can go like that. These are the same circles, so there we go, common tangents. Tell how many common tangents the circles have and draw them. Okay, the first example, I have 4 common tangents. It's going to be hard to draw here because they're so close. I can go 1, 2, 3, and 4. This next example, I can only draw 1. Oh no. 2, 3. Oops. In this last one, I can only draw 2. Very poorly also. Sorry, you get the idea. Let's try one more time. Accuracy is not a strong point of drawing on the iPad. I'll just make it thicker. Alright, I lied. Let's try one more time, because that's just embarrassing. There we go. 2. Alright. Tell how many common tangents the circles have and draw them. Here I can just draw 2. Here I can just draw 1. And here I can draw 0. None. Theorem 10.1. In a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at its endpoint of the circle. So this is really important because we're going to use this to do some calculations. I have a tangent. Line M is tangent to circle Q only if and only if line M is perpendicular to QP. Okay, let's erase this stuff and look at it again. I have circle Q. QP is the radius. Line M is tangent to circle Q if and only if it's perpendicular to segment QP, which is the radius. Okay, we're going to use that to do some calculations since we learned so much about right angles and right triangles. In the diagram, PT is the radius of circle P. Is ST tangent to circle P? Okay, this would be my right angle if it is. How do we know if that's a right triangle? Pythagorean theorem will tell us. So if we did 12 squared plus 35 squared equals 37 squared. Let's calculate that really quick. Yes, it is. We know it is because it forms a right triangle. We know it forms a right triangle because a squared plus b squared actually equals c squared. So ST is tangent to circle P because it is perpendicular to the radius, PT. Example 5, find the radius of the circle. In the diagram, B is a point of tangency, so AB is tangent. Since it's telling us it is, we know that this is a right angle. Find the radius R of circle C. Okay, focus in on this example. There's going to be a few of these in your homework, and I want to make sure you know how to do them. All right, Pythagorean theorem. I have a squared plus b squared equals c squared. Okay, we're going to have to reach back to some Algebra 1 skills for this problem, but 80 squared is easy. 6,400 plus r squared. Okay, this is foiling. You guys remember how to FOIL? 50 plus r times 50 plus r. We get first outer plus inner plus last. So we can write that in right here. 2,500 plus 50r plus 50r plus r squared, and solve our problem. I have r squareds on both sides, so those cancel out, luckily. 6,400 equals 2,500 plus 100r. Subtract 2,500 from both sides. 3,900 equals 100r. Divide both sides by 100. R equals 39. A lot of work for that one, but it wasn't that difficult if you remember how to FOIL. Foiling was the only hard part. Make sure I didn't miss anything there. Feet. All right, moving on. Another theorem, theorem 10.2. Tangent segments from a common external point are congruent. So I have SR and ST. They are tangent segments, so SR is congruent to ST. That also means that if I have a tangent here, PR, these are perpendicular, and here, those are perpendicular. Pretty cool. RS is tangent to circle C at S. RT is tangent to circle C at T. Find the value of x. Okay, we learned that these are congruent. So we set those two equations, or the number in the equation, equal to each other and solve for x. Got it. You try. Is DE tangent to circle C? That means we need to know if that's perpendicular. A squared plus b squared equals that whole thing too? Oh, no. Duh. The radius is 3. So 3 plus 2 is 5. It's a 3, 4, 5 triangle. 9 plus 16 does in fact equal 25. Yes, that was a close call. We must have made a silly mistake. ST is tangent to circle Q. Find the value of R. Okay, go ahead and try this one on your own. I'm going to push pause. All right, again, look through the work, make sure it makes sense. But R equals 7. All right, find the values of X. Okay, these two segments are tangent. You can tell by the right angles. They're perpendicular to the radius, or the radii. So we can just do x squared equals 9, x equals 3. Daily homework quiz. Page 1, page 2, page 3, last page. Try these out. They're pretty simple, 2 points.